Hello everyone. So in this question we are given the three questions and we have to solve that by the method of inversion. For that we will first write the three equations. So the first equation is 5x minus y plus 4z is equal to 5. Then we have 2x plus 3y plus 5z is equal to 2. And then we have 5z minus 2y plus 6z is equal to minus 1. So we have these three questions with us and we will represent these in the matrices form. So for that we will first take the coefficients of the equations, and the coefficients here we have is 5, minus 1, 4, 2, 3, 5, and then we have 5 minus 2, 6. This is to be multiplied by their variables, which is x, y, and z. And the result is also represented in the matrix form, which is 5, 2, and minus 1. Now we are assuming this to be matrix A. This is the matrix X and this is the matrix B. So we have AX is equal to B. Now pre-multiplying by A inverse, we have A inverse of AX is equal to A inverse B. Now A inverse multiplied by A is I. So we have IX is equal to A inverse B. Then I multiplied by X is X. Therefore we have X is equal to A inverse B. Therefore to find the value of X we need to find A inverse B. So for A inverse we need to first find the determinant of A. So for that we are considering this row where we have 5. 5 is to be multiplied by its minor. So we have 6 multiplied by 3, that is 18, then a negative sign, and then 5 multiplied by minus 2 is minus 10. Then we will have minus of minus 1, which will be plus 1 multiplied by its minor. So here this column and this row gets cancelled. 6 multiplied by 2 is 12 and 5 multiplied by 5 is 25. After that here we have plus of 4 multiplied by its minor. So this column and this row gets cancelled. 2 multiplied by minus 2 is minus 4. Then a negative sign, we have 5 multiplied by 3 is 15. On solving this, here we have that this is equal to 5 multiplied by 18 plus 10, which is 28. Then here we have plus of 1 and that is to be multiplied by 12 minus 25. So that is equal to 13 with the negative sign, and then we have plus of 4 multiplied by minus 19. On solving it, that becomes equal to 51, which is not equal to 0. So as determinant of A is not equal to 0, therefore we can say that A inverse exists. Now to find A inverse, we need to find the determinant of A, which we have already found out, and then the adjoint of A. So for the adjoint of A, we need to find the cofactors of A. So cofactors of A is represented by Aij, where I denotes the number of row and J denotes the number of column. So that is equal to minus 1 to the power of I plus J multiplied by its minor. Now to find A11, here we will have that A11 will be equal to minus 1 to the power of 1 plus 1 multiplied by its minor. So for that we will have that the minor of A11 will be 6 multiplied by 3, 18. Then negative of 5 multiplied by minus 2, which is plus 10, and 18 plus of 10 is 28. Therefore we have 28 here and that becomes equal to 28. In the similar manner we will find A12. So A12 is 13. We will have the value of A13, which will be equal to minus 19. The value of A21 will be equal to minus 2. Then the value of A22 will be equal to 10. Then we will have the value of A23, which is equal to 5. The value of A31 will be equal to minus 17. Then the value of A32 will be equal to minus 17, and then the value of A33 will be equal to 17. Now we will arrange these cofactors in the matrix form. Therefore, we will have 28, 13, minus 19. Then we will have minus 2, 10, 5. And then here we will have minus 17, minus 17, and then here we have 17. Now to find the adjoint of A, we know that adjoint of A is equal to the transpose of the cofactors matrices. Therefore, we will transpose this. So for that, we will have that this will be equal to 28, 13, minus 19, minus 2, 10, 5. Then we have minus 17, minus 17, and then here we have 17. After that, as we have the adjoint of A and here we have the determinant of A. To find the A inverse, we have the formula which is 1 upon determinant of A multiplied by the adjoint of A. So we will substitute the respective values where the determinant of A is 51. Therefore, we will have that this will be equal to 1 upon 51 multiplied by, so it is 28, 13, minus 19, minus 2, 10, 5, minus 17, minus 17, 17. Here we have find the A inverse. Now to find the value of X, it is A inverse multiplied by B. So here we will have 1 upon 51 multiplied by 28, 13, minus 19, minus 2, 10, 5, minus 17, minus 17, 17 multiplied by B. So the value of B which we have is 5, 2, minus 1. So we will have that. So here we will have 5, 2, minus 1. Now to have the matrix multiplication, here we will have that each of the row is to be multiplied by this column. Therefore, we will have that this will be 1 upon 51 multiplied by, so 28 multiplied by 5, that is equal to 140, minus 2 multiplied by 2, that is equal to minus 4, and then minus 17 multiplied by minus 1 is plus 17. Similarly, here we will have 13 multiplied by 5, which is equal to 65. Here we will have plus 20 plus 17. Here we will have minus 95 plus 10 minus 17. On solving it, that becomes equal to 1 upon 51 multiplied by 153, 102 minus 102. And taking 1 upon 51 inside, here we will have that this is equal to 3, 2 minus 2. Therefore, we have the value of X is 3, the value of Y is 2, and the value of Z is minus 2. I hope you now have a better understanding of the question. Thank you.